In this video, we are going to learn about how to graph absolute value functions, another type of nonlinear function, meaning a function that does not make a line. So in a very recent video, we checked out how to graph quadratic functions. We're going to do something very similar here. Remember that you can pick x values, any x values you want, put them into the function, get out y values, and graph the ordered pairs that result. And that's what we're going to do here. So I'm going to give you two graphs. We're going to do them both on the same graph at the same time. Y equals the absolute value of x, and y equals -3 times the absolute value of x. Recall that the absolute value of a number is the number's distance from 0. So if I take the absolute value of a number and it's negative, its distance from 0 is still positive. So let's go through, and I'm going to pick the same symmetric numbers I picked in the quadratic functions video. So I'm going to pick, for symmetry purposes, -2, -1, 0, 1, and 2. And I'm going to pick that for both of these graphs. And all we need to do now is plug in -2 through 2 into our functions, get y values, and plot them. So I'm going to plug in -2. So that means we're going to take the absolute value of -2, which is 2. So our ordered pair is -2, 2. Beautiful. Then I'm going to take -1 and plug it into the absolute value. The absolute value of -1 is 1. Its distance from 0 is 1. So the point is -1, 1. Sweet. All right, you bet we're going to plug in 0. So I plug in 0. The absolute value of 0 is 0. And so 0, 0 is our point that we have there. Then 1 I'm going to plug in. Well, the absolute value of 1 is 1. So the point is 1, 1. Nice. And then we're going to plug in 2. The absolute value of 2 is 2. Okay, so let's plot those points, and then we'll go back and do -3 times the absolute value of x. 2, 2, all the way through to -2, 2. Let's do it. Well, -2, 2 is going to be left 2, up 2. Bam! -1, 1 is over here, left 1, up 1. 0, 0, plotted right at the origin. Nice, right there. 1, 1, right 1, up 1. Ah, notice the symmetry. Here we go. 2, 2, right 2, up 2. Oh yeah. So these are lines. I'm going to draw it as straight as I can. And it gives you a V graph. In fact, all absolute value graphs of just nice linear functions, meaning you have like x with no power above it, are going to be nice V's. Let's do one more. Let's see what happens. We'll do -3 times the absolute value of x. So we do -3 times the absolute value of -2. Your order of operations has you doing the absolute value, the grouping symbol first. It's like parentheses. Absolute value of -2 is 2 times -3 is -6. So that's the point, -2, -6. Here we got -3 times the absolute value of -1. The absolute value of -1 is 1 times -3 is -3. Ah, so that's the point, -1, and the output is -3. The absolute value of 0, we're going to use here, is 0 times -3 is 0. So that's the point, 0, 0. Awesome. 1, well, the absolute value of 1 is 1 times -3 is -3. Doing all our work in the center box and getting the point 1, -3. Beautiful. Finally, we plug in 2 into our function, -3 times the absolute value of 2. The absolute value of 2 is 2 times -3 is -6. So we get the point 2, -6. So remember, all we did is plug in the x values to find the corresponding y values. Now we're going to plot them all. -2, -6. -2, down 6. That's down 1, 2, 3, 4, 5, 6. Woo. Then we got -1, -3 here. Then from there, after we got that point, make it a little darker. We got 0, 0. Huh, it's a little steeper. Then we got the point 1, -3. Over 1, down 3. And finally, we got the point 2, -6. 2, -6. All we do now is connect those points. Interesting. And we see that we have steeper slopes here for those lines. And it's flipped downwards. I bet the negative has something to do with that. And I bet the 3 has something to do with the steepness. It certainly does. In later math classes or in later videos, you'll check out why those numbers, that -3, affects the graph of absolute value of x the way that it does. On the flip side of this video, we're going to go over one more graph of absolute value functions, and then you'll be ready to rock and roll to graph absolute value functions by plugging in x values and getting out y values. Awesome stuff. See you on the flip side. And here we are on the flip side of the video where we are going to graph the absolute value of x minus 5. Just a little extra practice, so without further ado, let's dive right into it. I'm just going to plug in these numbers, -2 through 2, into my function. The absolute value of -2 is 2, minus 5 is going to be -3. So that's a point -2, -3. The absolute value of -1, just plugging that in, is 1, minus 5 is -4. That's the point -1, -4. The absolute value of 0 is 0, minus 5 is -5. So that's the point 0, -5, not bad. The absolute value of 1 is 1, minus 5 is still -4. So you get the point 1, -4. And finally, the absolute value of 2 is 2, minus 5 is -3. Notice the symmetry in those y values. We have two -3s up there. Two -4s. All we got to do is plot those points. We're going to plot -2, -3. Left 2, down 3. Then -1, -4. Left 1, down 4. Sweet. 0, -5. That's down here. Oh yeah. 1, -4. We got this. That's over here. And finally, we had one more point. It was 2, -3. That was right here. We connect those lines, or those points, to show all the points that are on that curve, and you get an absolute value, v, that is shifted down 5. More on that in later videos with why there's a shift. For now, plug in x values, get out y values, and plot them, and you'll have yourself awesome absolute value graphs.